Thank you, Harland, and thank you all for still being here late this afternoon. I think it's really at the Johannesburg World Summit on Sustainable Development, the Rio Plus 10 conference, that a number of people started sharing this vision that we need to create a world where decisions and actions will be informed by coordinated, comprehensive, and sustained Earth observations. I was at this summit representing the space agencies at that time and trying to convey the message that satellites and space technologies would not just be used to explore other planets or the universe, but could actually be a very good platform to observe and understand our own planet. Shortly after, a few months later, a group of countries, about 25 countries, and international organizations, among them UNEP, WMO, UNESCO, FAO, gathered in Washington at the invitation of then Secretary of State Colin Powell to discuss how we could actually implement this vision. And well, we came up with the idea that we should form a group on Earth observations. This group has then grown as an international organization with now 88 members and 64 participating organizations. What these people have recognized together is that our ability to observe the planet today is huge. We have dozens of satellites which are circling the planet and watching the oceans, the lands, the atmosphere. We have the World Weather Watch system which contributes to weather forecast every day. And we also have much simpler in situ observations of trees and the amount of carbon that is stored in forests, and even simpler observation like this one, which is a very low technology as opposed to those satellites. The problem with all these observations is that they're so different, and even when you talk about the satellites, they've been developed by different agencies, different engineers with different standards. So they don't talk to each other. They can't exchange data. It's a little bit like the biblical situation of the Tower of Babel. They can't communicate. They can't talk to each other, and hence they can't work together. So this was the first challenge to address. The second thing which we recognized in Washington was that all the problems that we have to deal with today are closely linked. The Earth is a system of systems. So addressing the blue carbon, agriculture, urban growth, natural disasters, ecosystems, and biodiversity changes cannot be addressed and studied independently of each other. They have to be observed and addressed jointly. Yesterday, President Clinton gave an interesting example in Brazil of a problem that President Dilma Rousseff has to deal with, deciding between hydroelectricity extension, preserving the forests, and allowing for more food being produced. This is not just a problem for Brazil, it's actually a global problem. And this slide gives a very good narrative of the problem. We have about 14 billion hectares of land available on the planet. Out of this, 1/3 is deserts and cities and land which cannot be used. Another third is forests. And finally, the last third is for food production. And that's it. How much we can extend, add additional land for food production is probably another 20%. Certainly not enough to accommodate for the extra 2 billion people who will be joining us pretty soon, before 2050, and also the increase in wealth and demand from many parts of the world. So how can we increase agriculture and food production? without reducing the forest's surface, because forests provide biodiversity conservation, they store carbon, and also expansion of cities in order to let these 9 billion people live. So these problems are coupled, and they have to be addressed together. The solution that was proposed by this group on Earth observation was to develop a global Earth observation system of systems through which we could have coordinated access to information, to observations, to data. That's this green sphere which brings together all the satellites, the buoys in the oceans, the in situ observations in the rivers, in the air, and the models, the modeling capabilities, and they can be used to inform decision-making in these 9 societal benefit areas: disaster, health, energy, climate, agriculture, ecosystems and biodiversity, water, and of course, weather prediction. Now, with the Iron Earth Summit, we're thinking of extending this system of system or rebranding this system of system as a network of networks. I think it's much more than rebranding. It's an extension, because I guess with the system of system, we really had in mind the systems, the devices. With the network of network, we're going to bring communities on board, communities of practice, and also actually new communities. NGOs, for instance, are not involved in the group on Earth observation. They would be part of the network of networks. So it is an extension of the same idea. It's all for the better. Let me give you now an illustration of what is a network of network and why it's needed. And I'll use 2 examples, the water cycle and food production. Monitoring the water cycle requires observations from space, in situ, and models. So this is a very complicated diagram, but it's on purpose, and don't worry about the details. But we have a lot of observation in space. We also have observations on the ground, and from that we can build hydrological models and predict river flows. We can actually measure river flows and compare and validate the models. We can also include numerical weather prediction and, again, contribute to the model. And eventually, we'll get an integrated water management. Things can get even more complicated, because you can add soil moisture that you can also measure from space and actually from the ground. You can use land surface measurement, get surface flux, validate this, even go to subsurface water measurements from space and in situ. And all this together will, again, allow you to produce drought index, flood index, and integrated water management. And you can add seasonal prediction and even climate modeling. And with climate prediction, you can start looking at the biases in the system. You can modify your index, and eventually you get a completely integrated water resources management. So this is a network of networks. Actually, this is a system of systems. But if you factor in all the communities that are working behind these different models, these different acquisition systems, different in situ observation systems, then you get a network of networks. But it's not really complete, because there's one thing missing there, which is the societal dimension. This is purely technical. It's an integrated water management which ignores the existence of humanity on this planet. So let's get to another example, food security, and see how we can further integrate the system of the network of network into it. This is a very interesting diagram, because it summarizes very well why we have a problem with food and why we have such volatility on the food market. Essentially, over the last 40 years, we see that our consumption of food, and this is only cereals, has increased up to 2.2 billion tons, and production has followed. But stocks have not. They've remained almost flat. They're the yellow bars, and they're just 20% of the annual need. And trade, that is the amount of grain that is available on the market for trading, is only 12% of everything. So a very small change in the production will affect the whole market. So again, we've seen how Earth observation could contribute to addressing this question and providing information for our decision makers. And again, this project that GEO is conducting is bringing together Earth observation, agronomy, meteorology to predict, well, to measure planted areas and to make a prediction on how much the yield, try to forecast the yield on a given year. And that provides this green box, which is the supply. But it's only one part of the equation. And so this green part, the GeoGlam project, provides the supply part. But in fact, if you really want to understand the production of food and ensure food security in a much larger information system, which integrates demand, stocks, the communities, the energy policies we've seen yesterday, the best practices and everything. And that's what this AMIS information system that FAO is developing is about. And the real network of network that we should be aiming for is that one, the one in the red bubble, the very, very large one. So to introduce now what the discussion is going to be on the panel, the GEO, the Group on Earth Observation, has already developed or contributing to developing a network of network to inform decision. We've created a GEO portal and actually a system which we call the GEOS Common Infrastructure, which integrates a portal and a few other devices, the registries and clearinghouse. And essentially, that's what it looks. The GCI has its own resources, but, and this has been a recent change, it's also connected to a broker, which happens to be a software. It's not a person. And the broker connects to other catalogs which already exist and which are not necessarily compatible with the GCI in the very beginning. So by that, any user can enter the GeoPortal and the GCI and get to an incredible amount of resources. And by introducing this broker, we've actually been able, in just a couple of months, to bring the amount of resources available through the GeoPortal to several, 2 or 3 tens of millions of data, several thousand services, and a few hundred observation systems. It's not the end of the story, because there are many challenges, and that's these challenges that we're going to be discussing later on at the round table. Of course, data policies is the most important. Some of the resources are available, existing somewhere, but may not be fully and openly available. So we are pushing through GEO to convince people to make as many data as possible openly available. But there are some which are commercially available, and they may be needed. And there are others which, for security reasons, are restricted access, and yet they may be needed to really inform the decisions. So that's a very important issue. And we'll also be discussing interoperability issues, the Tower of Babel issue, the standards and formats, and even the semantics. If someone comes to the system and wants to have data about rain and types rain, well, if somewhere a data set is stored as precipitation data, well, this problem has to be addressed. And it sounds silly, but it's very important. So we're going to be discussing these challenges at the round table. And I guess if we're able to address them, solve them, and expand this system of systems into a global network of network, as the Iron Earth Summit is inviting us to do, then I'm convinced that the benefits will be enormous. Thank you.
Thank you, Jose. So you've just heard a summary of one very large global geospatial network, and so I'd like to call out the rest of our panel and to come out and be seated. And so we're going to start our panel discussion by asking each of our additional speakers to talk about a network that they are involved in or managing either on a global or a major regional basis. So we'll start with Erik van Praag, and Erik coordinates the regional Hosur program.
Okay, thank you, Harlem. Well, good afternoon to everyone. You know, I'm Latin American, I'm from Venezuela, so I like to make this like a short story. You know, we like to tell stories in Latin America. The story is about the development of a regional network in Latin America. And so let's backtrack a little bit. You know, let's go to 2007. I'm sitting at CAF, the Latin American Development Bank in Venezuela, where the headquarters is. And, you know, we were thinking about how to integrate data supranationally across boundaries. And there is a project that CAF, IDB, and other agencies are developing called IRSA, the Initiative for the Integration of Infrastructure in South America. You know, it turns out IRSA is building roads. They want to take into consideration environmental topics, but they don't have the data. You know, they only have the national data. You know, and the point is, if you want to protect regional environments, like let's say the Amazon basin, you know, you need, you know, Brazil is fairly advanced. So Brazil have a very good monitoring system. But you need to integrate the Brazilian data set with data from Colombia, data from Ecuador, data from Peru. They also have big chunks of the Amazon basin. So how do you do that? You know, so we started thinking about this, and we had actually tried to develop a couple of sub-regional networks that didn't work out so well. And we came up with the idea of doing Hosur. You know, Hosur is a regional network. We started in 2007. And we thought, you know, let's invite data producers. You know, let's invite the mapping agencies of South America. Let's invite the ministers of environment. Let's get them on board. Let's do it decentralized. And with that, we started building Hosur in 2007 with a cradle of institutions that were ready to participate. You know, we gave them some incentive. You know, it's going to be decentralized, so you handle your own data sets and so on. And we have quite moved a long way, I think, with Hosur. You know, 5 years later, we have 22 countries participating, all of the countries from Latin America and a good chunk from the Caribbean. We have 50-odd agencies that are participating, and they're all developing services on their own terms. It's very flexible to participate. And we have put together some SDI infrastructure, you know, the regional portal, regional geoservices. But each one of them do their own thing, and we integrate them. And you know, we were looking only in Latin America back then, and I get a call from UNEP, March of this year, and they tell me, you know, why don't you go to Eye on Earth and present this? You know, this might be worthwhile. So thank you to UNEP and to AHEDI. We started looking at Hosur, you know, asking ourselves, can you replicate something like Hosur in other parts, at least of the developing world? So we got a little bit of funding. We produced a report that I still have a few left if some of you are interested after the talk. And we started looking at things that work and things that haven't worked in Hosur. So, you know, I'm going to end it here just to give you a nutshell of Hosur, but later on as part of the conversation, I will explain some of those lessons learned as part of the Hosur program. Oh, thank you, Mick. Mick is the guy actually who called me in March. Thank you.
All right, thank you, Erik. So let's move on to Stephen Ramage. Stephen is the Executive Director of Marketing and Communications of the Open Geospatial Consortium, and he's also the Chair of the Outreach Committee of the GSDI Association. Stephen.
Okay. Is this going to work if I stand up?
Sure.
So I've been sitting down all day, so I can't be bothered sitting down anymore. First of all, I'd like to say that I'm Scottish and not Irish, for all those people who keep calling me Irish. I just want to get that out of the road. This is about Beyond IT, this is called. So one of the things I'd like to do is quote the founder of the Open Geospatial Consortium, the OGC. He said that interoperability is seemingly about the integration of information, but actually it's about the understanding of organizational behavior. And I think that's really important. I think that's one of the things that we haven't heard enough of this week, is talking about individuals and talking about behavior and talking about what are the incentives and what's the motivation for people to do this, because all of this stuff we're talking about is about people. So to describe OGC a little bit, every single one of these gentlemen and their organizations are involved with OGC. So at a very simplistic level, OGC is a network of networks. We're involved in GEOS. We are doing the Standards and Interoperability Forum. We do the GEOS architecture implementation pilots. OGC standards are used as part of the technical guidance, or they're close to the technical guidance for Inspire. You know, Inspire at the moment is something like 10,000 public administrations. You know, Alessandro and I were chatting earlier, maybe by 2020 this could be something like 100,000 public administrations. Then we have Eric talking about Hosur. In South America, there's something like 30 different countries and regions that are using OGC standards to provide access and interoperability to geospatial data and services. And then Harlan, on the GSDI Association, they're an alliance partner of the OGC where we work with them on spatial data infrastructure. So the OGC is a network that's plugged into all these different networks. If you look around the meeting here, you have all these organizations. You have the European Environment Agency, you have ADSIC, you have Microsoft, you have Google. All of these organizations are OGC members. And they're all working together on a consensus basis to try and deliver standards. But the thing that makes it work is it's individuals who lead the activities. So within the OGC, we have 54 working groups, which are split into domain working groups, which are thematic areas, and standard working groups, which are technical areas. And they range in the thematic areas from things like meteorology and oceanography, emergency disaster management, defense and intelligence, hydrology. We have a range of different areas we cover, which all have relevance to the discussions here. And then on the standards working groups, we have a number of areas from geosemantics to data quality to decision support to metadata. And that's where all the exciting stuff happens, apparently. So with that short introduction, I just want to say that I'd like to see, if we're talking about beyond IT, that we talk more about the incentives and the motivations for people who are involved in the community and how in a network of network we can bring those people together. Thank you.
Thank you, Stephen. To talk about our next exemplar network is Alessandro Annoni. He's head of the Spatial Data Infrastructures Unit at the Institute for Environment and Sustainability of the European Commission Joint Research Center.
Thank you, Chairman. I would like to say that Inspire is considered one of the main contributions to GEO, and Inspire is also a network of networks. We have today 486 spatial data needs community that are participating to Inspire program, 286 legally mandated organizations that are basically the organizations that have to provide the data, that they are engaged in developing Inspire. What is Inspire? Inspire is an initiative that was launched by the European Commission in 2001 to create a European spatial data infrastructure to support policy making for environmental policies, but also for the other policies that can have an impact on environment, like transportation policies or spatial planning and so on. Inspire is a legal framework, and I will try to explain why this approach was chosen. Europe is a patchwork of 27 countries with different cultures, with different data management practice, and 23 languages. The only way to be sure that all these countries were committed to the common objective and having a common roadmap was to put this in the context of a legal framework. And the legal framework was developed, and this is something that I give you as a message, in a very open and participatory and inclusive approach. So the member states were involved in designing the legal framework. Since the beginning, we create an expert group with representatives for the environmental sector, for each country, and for the geographic information sectors. All these experts were drafting orientation paper and then position paper, and they were the basis for the Inspire legal framework. But Inspire was making other choices that are very important. First, Inspire is building on the top of national spatial data infrastructures. This is important because there is a large degree of freedom from each country to set up the more appropriate way to develop a national spatial data infrastructures. So they can do according to what they have already in place, according to the national asset that exists. Secondly, INSPIRE is focusing on the interoperability of this national spatial data infrastructure. So we try to define common rules for the network services and for data specification, common data specification, to make possible to transform national data set in agreed European common specifications. So the cost of INSPIRE is minimum because it's based on the fact that this information exists and is focusing on making this information accessible and discoverable. The last point that I would like to stress that we are also using a stepwise approach. The cost of any infrastructure can be diluted in the time if there is a stepwise approach with progressive implementation, and this is what is happening in INSPIRE. Since November 2001, we have the first INSPIRE services in actions, so you can start to discover and view the data that are available in Europe. Next year, at the end of next year, you can start to download the data, and progressively you will be able to download harmonized data until the end of the project, that is 2020. Thank you.
Yeah, thank you, Alessandro. So you've just heard kind of a short synopsis of 4 exemplar networks, but of course there are many, many more that are existing in our community, certainly as exemplified by many of those that we've already heard about at this particular conference. So I'm going to ask the following question first of our panelists, and then what we'd like to do is simply open it up to comments and additional questions from the audience. So my question is, then what are some of the challenges and opportunities as well to enhance the collective impact of all of our organizations in improving the quality of the planet? And again, we'll start with Jose again. I think you've already highlighted some of those, and maybe you could just review them again to kind of start this off.
Yeah, I'd be happy to get the debate started, but they were presented at the end of the introduction. Well, clearly the data policy is the most important, and goes way beyond IT, which was supposed to be one of the subtitle of this this conference or this talk. But then there are a few technical issues like interoperability of systems and the ability for the systems to be able to communicate. That's the dimension of standards and formats. And finally, I was also listing the question of semantics and the question of making sure that whatever way the query is formulated, it is understood by the system and it provides the appropriate answer. And this is a problem that you may face when you're searching in Google for just simple things. When it comes to Earth observation data, images from space, measurements of rain, gauges, salinity in the ocean, well, there might be a number of vocabularies that are used in different places, and we have to establish the mechanisms. That's what these people are doing, is to make sure that all these systems can actually exchange and communicate with each other.
So, Stephen, agree?
I do. I pick up on, I call it something different. I call it shared understanding. So if I give an example of a flooding, so if there's a flash flood or a river floods, you have a number of people who have to go to that area who are interested. So you have volunteer technology communities, you have emergency responders, you have hydrologists, you have people who are interested in the weather. So you have a whole host of different people who are all trying to get a common picture on the same place, which part of it is a semantics about how you describe things and speaking the same thing. But part of it is just basic communication and being able to get that through to people. And that's part of the challenge. I mean, within the OGC, we call it cross-domain modeling. And that's something that I see happening more and more as borders or boundaries disappear. people trying to tackle that. So that's the first part, which is this, I guess, the semantics and part of the interoperability bit. The second part is there's mind the gap. You know, there's this gap between the people technically doing the work and the policymakers. And there's this translation requirement in the middle. And there's very few translators. There's a lot of people who think they're translators, but there's still, someone once described me as a geek in a suit. And I think there's quite a lot of people still there. We still need to get to the next level and do that translation.
Yeah.
And actually, there was one important thing that's missing in my list. It's timeliness. It's very important that the information that is provided by these networks of networks is timely. In some cases, you have plenty of time. You're making a model on climate change. You're talking about years, decades. But if you're managing natural disasters, you need the image. You need the information immediately. And this response time of the system is also a big challenge.
Okay, so we have a lot of challenges, continuing challenges on the table. Perhaps for every challenge, it presents an opportunity. Are there additional challenges that you would like to, Alessandro, or are there other opportunities as well that could make us all work better together?
Thank you, Chair. When there is a difference between designing a spatial data infrastructure and implementing an operational spatial data infrastructure, and we touch in the last 10 years, and we learned a lot of things that were not in our mind when Inspire was designed. When we started, we believed that the main problem was the technical interoperability. It's not. The main problem is all the aspects of interoperability that you have to consider. As I mentioned in data policies, you can imagine how you can try to find a compromise solution between 27 different policies in the member states, and within the member states, several data policies that are different between the different sectors that are touched by Inspire. This is a very big challenge to agree on common principle for data sharing. The second big challenge is about what we called before, the multidisciplinary interoperability. This is a dimension that is very, very critical. All the spatial data in the community, and we have the example in this summit, you have a very excellent network. These networks are fully aware about what should be done, how to do this, but they're not talking each other. So when you try, like Inspire, to have the geological community talking with the soil community, you discover a lot of differences of view, a lot of different objectives, goals. And this is very difficult to make this community agreed on common goal. The last challenge is what is feasible, which are the cost and the benefit of the attempt to create such infrastructure. And you cannot have the same level of visibility in all the data teams that are covered by Inspire. Inspire is covering more than 30 data teams. It's not considered like classical infrastructure in which only topographic data are regulated, but it's dealing with all the environmental data. So you can imagine that the sector are starting from different point of view. So the topographic, the nature mapping agencies are normally well organized in terms of data management practice, and then you go to data teams in which you don't have any community of practice in existing. So the balance in what can be justified by the users and in terms of cost of the implementation is the trick challenge. And in Inspire, we have adopted an approach in which each thematic working groups should define which is the right balance.
Thank you. Here.
Well, I hate to be last, because I think my colleagues have already covered some of the challenges that I wanted to cover myself. Luckily, they left some of them out, and I think one particular thing about Hosur, I would say the first particular thing is that we're doing it in the developing world. So we face different challenges that Alessandro will face in Europe, for example. One of them is that we don't have a legal mandate. So I would say the first challenge is actually to get the network off the ground. And that, that means a lot of hard work to convince agencies to participate. That's the first thing. And that's one of the things we learned through this exercise we did with UNEP and AHEDI funding. I think the second challenge, and probably the major one, is that you build a network that is useful for something. You know, in the case of Latin America, we're trying to look at environmental challenges, you know, monitoring the Amazon basin, you know, see what is happening with the forests in the eastern part of the Andes that are very rich in biodiversity. And around those topics, trying to build services that are useful, because you can build a network that is a very abstract concept, so you have it out there and nobody's using it. So I think that's the biggest challenge is to build concrete, real applications, you know, that people are going to be using them and they're going to be taking decisions that are useful for everybody else, you know. There are many challenges, you know, in Latin America to build a network. I will say another challenge that comes to mind is, you know, we're dealing with agencies that have weak technological infrastructures. You know, sometimes a hard drive breaks down in Bolivia, in the mapping agency of Bolivia. It takes 3 months to replace it. You know, the system is 3 months off the line, offline. So I think one challenge is, you know, using cloud services, you know, using new technologies to get some of these agencies that have very good data, but they cannot get it out there, to help them to get it out there. You know, and that's one of the proposals we put into the white paper of my working group, is having a cloud service for open source geoservices that can be shared and that can be low cost, and they can have these services running continuously, you know, with good performance. There are many more challenges, but I won't tell you them all, so you can take a look at the report later on.
Well, what I'd like to do, we only have a few minutes left, so I thought we could go to the audience if there are 1 or 2 questions out in the audience or comments that anyone would like to make. Right here. Is there a microphone?
Huh? That's what I think. Yeah, we have another 20 minutes.
Hi, my name is Martine Mamlouk. I'm with the French Embassy here, representing France to IRENA. I have 2 questions. One that you partly addressed just now. My concern was when I hear it, so far we're only 84 partners, which is a big number, to GEOS. I'm wondering how we're going to bridge the gap, because we know that we will not be able to deal with data if the data is not fully completed in terms of interaction and holistic approach. My second is related to my main field of concern now, which is the renewable energies. What can you provide in terms of information to help us to set up the knowledge what we need to gain in terms of potentials in renewables, and how do you see the articulation between what we plan in terms of creating an atlas of potentials for renewables within IRENA in cooperation with a certain number of countries, and with what the work is going on between your different organizations. Thank you.
Well, I think if we start moving beyond the IT questions, there are a number of additional challenges, and what we just heard are a few of them. The first one is that eventually all this is meant to produce information, not just data, not just observations, but actual information for water management. And what I've showed in this diagram is that it's awfully complicated. And actually, we had an interesting presentation from Microsoft this morning, where they seem to be hoping that they're going to be able to solve the whole problem of this interconnected systems. They're all nonlinear. Each of them is nonlinear. There's nothing worse for a physicist than two-coupled systems. So if you couple 2 nonlinear systems, it's a nightmare. And if you couple 12 nonlinear systems together, the whole thing is just unpredictable. So trying to see how we can generate information out of this complicated system with observation is a major challenge. Then the second one is how people can use it. And it means building capacity. And the answer will be building capacity so that people can actually use the system and be able to use it. That's why in Geo, we have, next to our activities, we have a very substantial capacity building set of activities. And for non-Geo countries, there's no problem, because the beauty with Geo is that anything that is being developed, and GEOS in particular, and all the resources connected to GEOS, are openly available. You don't have to be a GEO member to access to GEOS and use it, and even to contribute it. It's a fascinating kind of intergovernmental organization or arrangement. It's non-binding. Anyone can become a member fairly easily. There's no mandatory contribution. And actually, you can benefit from GEO even without being in GEO. So that is probably, this is, I guess, addressing this, this thing, your question. At least building capacity is very important. And with every program that GEO initiates, there's a capacity building one. And in forest observation, most of what we're doing is building capacity in the countries to do national forest inventories and forest monitoring. In GFOI, in the food security issue as well, we're essentially building capacity with all countries. And that way we're hoping to bridge the gap and involve everybody in this network of networks.
Other comments, questions from the audience? Right here? Oh, okay.
I was in Japan last week, and there were people bringing the microphones like that.
Hi there. Yeah, I'd like to follow on from
the
numbers mentioned by Alessandro about how many participants there are in Inspire, and then look at it in the context of GEO and a global organisation. And also to take on board Eric's comments about delivering something useful. There are many, many information products that need to be generated at many different scales, and there are many different ways of generating each of those information products, and they'll be refined, and as new information becomes available, new monitoring, new citizen science, we'll be continually adapting and growing. Do we need a new paradigm for the governance of global systems to allow us to cope with that level of scalability, of engagement, and of delivery of information products above and beyond what GEOS currently has? And if so, how do we get there? And if not, why not?
I have an answer to that, but I don't want to keep...
Yeah.
Who wants to respond?
Yeah, I can respond from the Inspire point of view. We are aware about the potentiality to open Inspire to a closer collaboration with the private sector and with citizen engagement. Meanwhile, we have to consider that it's a legal framework, and then we have to consider that we need some time to raise the awareness about the public administration to modernize the way in which they were working, and they need some time. So we cannot change too much until that we have at least achieved the baseline. That is what we want to have at the beginning, all the public authorities engaged to share their data. Meanwhile, we are already starting in parallel actions, and one example is the workshop that we are organizing next year at the Geospatial World Forum, in which we have a specific section on public-private partnership. We want to have a discussion, a serious discussion, how the small, medium enterprise of Europe or how the big industry can help in developing European spatial data infrastructures. We have already today a lot of interesting examples coming at the national level. A lot of the actors that are implementing Inspire in their countries are already establishing agreement with small, medium enterprise to create value-added products. They are giving free access to the data, and these small enterprises can provide value-added services, so they can generate new jobs, and at the same time provide services that are interesting for the users. It's still difficult in Europe to convince about citizen engagement. There is still a conservative culture of public authorities to be in collaboration with information provided by citizens. But at least as a Jersey, we believe that is something that should be done, and we are trying to push also to open this direction.
Okay, I think we have time for one more. Gilberto?
My question is to Jose and Sandro. You've been involved in setting up systems for a decade. The GEOS is about a decade, Inspire has about a decade. And so that decadal experience, would it translate into a certain sense of awareness of the size of the task that we're doing, because what we saw in Eye on Earth is, in one sense, a certain importance of geospatial data. In the other sense, we saw a techie bloat, where you have technical companies coming here with the latest solution who is going to solve the problems. So I wonder, from your 10 years of experience or 20 years of experience, what could you say to the others who have just been exposed to this techie bloat that will solve the world's problem immediately?
Well, we've been making progress constantly. I really started considering these questions of building information and producing information to inform decision making about 12 years ago, and we started building GMES in Europe, and in parallel with Inspire, but GMES was probably closer to what GEOS is trying to achieve. And then we moved on to Geo and the GEOS, and we've made significant progress. We've moved from this technological push, which was resisted by most communities. And I guess, again, the major shift was made in Johannesburg, when we managed to convince the so-called environment community that satellites are not just garbage and technological devices in the sky, but can actually be used to promote and help achieving the Millennium Development Goals and sustainable development. So that we're making progress in this direction. We're not there yet. And as we just discussed in the previous section, GEOS, for instance, as well as Inspire, are intergovernmental initiatives. It is clear now that we have to go one step beyond. And actually, the Eye on Earth Summit and this network of networks is inviting us to do so by having the NGO community as well as the private sector attending and involved. Indeed, the number of services that can be produced and will be produced will increase, and they will probably have to be tailored for specific user communities. And to some point, some of them might become commercial services. And I think it's important that we maintain the momentum in order to keep an open, interoperable system of systems or network of networks which can be used by all potential users, and that starts with governments and public interest, but it goes to the citizens and to NGOs, but also to the private sector. There's no reason why they should be excluded, and why we can use this network of network to actually provide information that and contribute, if not allow the development of the green economy. I'm convinced personally that we need this network of network in order to make the green economy a reality. I guess what I'm saying here is no different from what President Clinton was saying yesterday, by saying we have to prove that we can actually create good economic solutions which yet will be respectful of the environment. And contributing to economic growth, contributing to making the green economy a reality, I think is one of the objectives and one of the key contributions that the network of network can make.
Alessandro?
Yeah. You make me younger, but I have more than 35 of experience in developing information services for public authorities. And in my previous career, I was on the private sector side. So I was one of the people selling technologies, developing software, and trying to convince authorities that they have the best solutions for their problems. Now I have 15 years of experience on the public sector side, and I can say I am more skeptical about the fact that the latest technology is solving your problems. I don't think so. I think that we should be able to profit of the advancement in technologies, but always with a critical approach, not to be driven by the latest technologies, because otherwise you are changing your system every day. Technologies are changing so frequently that you cannot follow. You need to have in mind which is your strategy, and which is the best strategy to create a network. It cannot be a strategy to use a single software or a single platform. It should be the capacity to connect all the existing systems, minimizing the investment or the reorganization or the impact of all these authorities. And this is why GRC was involved in the development of the EuroGeos broker. We believe that instead to ask that everybody standardize using the same component, etc., that will take decades, we need to act now and to be able to interact with what is existing. And then when we have created this kind of network of really people that are sharing the data and without being, I would say, annoyed by huge amount for engineering the system, they will not do. This is the experience that I have. The W Meteorological Organization, just to make an example. They have a meteorological infrastructure that has been developed in 50 years. It's very operational. It's performing very well. Why they have to change? We need to adapt what we are proposing in order to connect to what they have. And don't expect that they are changing because we say, oh, you have to change, you have to adapt to something else. So the approach is, we need a strategic vision. We need to understand how to connect the different pieces, and then you use the best technologies that is in the market or is not on the market. But for me, brokering and mediation is the way forward.
Well, I think we're going to have to wrap it up there. Networks, of course, are all about links, cooperation, striving for common goals, and I think there's the I guess the goal and the struggle at the same time for all of us to better connect with each other and come to common understanding. So please join me in thanking our panel from this afternoon.